Assalamualaikum warahmatullahi wabarakatuh. Mendoa. Alright. So this one is the definition of acid and bases. Okay. Arrhenius and also Bronsted-Lowry. Okay. So for the Arrhenius, look at what is it? The definition. Substance acid. Substance that produce H plus or H3O plus ion when dissociate in water or in aqueous solution. Okay, example given them, HCl, liquid or gas plus H2O, HCl gas plus H2O liquid produce H3O plus aqueous plus Cl minus aqueous. Meanwhile, for the base, substance that produce hydroxide with minus ion in water or aqueous solution. Example, NaOH aqueous. Okay, so we produce Na plus aqueous plus OH minus. Okay, for this chapter number 7, the phase is important, you state it. Alright, and then definition of acid and base based to the Bronsted-Lowry. What is the acid? Acid is substance that can donate a proton H plus to another substance. Okay, so HCl aqueous, that is acid, one of the example of the strong acid, plus H2O liquid, so you will produce H3O plus. Okay, H2O plus, again H plus from HCl, and then plus Cl minus. Cl minus. Okay, Cl minus tak letak situ minus. Alright, tersilap. Alright, meanwhile for the base is substance that can accept a proton H plus from another substance. Okay, so for the acid, donate proton, so H plus being reject from HCl. Alright, and then for the base, NH3 will gain a proton H plus. Okay, base is a substance that can accept a proton H plus from another substance. Okay, example given, ammonia NH3 aqueous plus water H2O liquid. So ammonia is one example of weak base, HCl strong acid, and NaOH strong base. Alright, ammonia plus H2O liquid and then reversible reaction. Pasal tu dia jadi reversible reaction, pasal dia adalah weak base. Alright, so dia akan jadi NH4 plus aqueous ammonium ion plus OH minus. Okay, that is the base. Alright, and then according to the Bronsted-Lowry theory, conjugate acid base. Okay, conjugate acid. What is it, conjugate acid? A species form when a Bronsted base accept a proton. So dia akan jadi conjugate acid lah. The stronger the base, the weaker it conjugate acid. Okay, meanwhile for the conjugate base, a species form when a Bronsted acid donate a proton. Jadi yang mendonate dia akan jadi conjugate base lah. The stronger the acid, the weaker its conjugate base. Alright, so itu merujuk kepada definition lah. Alright, okay, so one example, kita tengok example. Identify the conjugate acid base pairs according to Bronsted-Lowry theory for the following reaction. So dia bagi HCl plus NH3 reversible reaction, Cl minus plus NH4 plus. Okay, so HCl of course acid lah. Memang solution yang you kena buat macam tu. Acid adalah HCl, base NH3, and then HCl dia donate H plus, so dia akan jadi conjugate base, and then base dia akan gain proton H plus, so dia adalah conjugate acid. Alright, okay, we go to the next one. The relationship between pH and pOH to ionic product of water. Okay, so formula yang first yang you all kena hafal adalah this one. Kw equal to the concentration of the H plus times the concentration of the OH minus. Alright, taking negative log of both side of equation. So kita negative log lah both side. So you akan dapat PKW equal to pH plus pOH. Okay. And then at 25 degrees Celsius, the KW is equal to 1 times 10 to the power of minus 14. Alright, and then we insert the value of the KW. So you do the calculation. Okay, lastly you akan dapatlah this formula. pH plus pOH equal to 14. Tolong ingat ini punya formula. Alright. Guideline for calculating pH value of strong acid and strong base. So step number 1, write the dissociate equation of strong acid or strong base. Jadi kita kena buatlah dia punya equation. And then determine the concentration of the H plus ion for strong acid or OH minus ion for strong base. After complete dissociate, dia kalau dia strong acid, strong base, dia mesti completely dissociate. Dia mesti satu je anak panah, forward reaction je. Dia tak adanya reversible reaction. And then you can calculate the pH value for strong acid and strong base. Yalah, kita dah tahu ada formula pH plus pOH equal to 14. Daripada situ kita boleh tahu whether pH ataupun pOH. Alright. Keyword strong acid and strong base. This one. Dissociate 100% in water. Maknanya 100% lah. Jadi dia punya degree of dissociate equal to 1 or 100%. Tak perlu kira dia punya degree of dissociate tu. X divided by inertia, right? So X dia 1, inertia dia 1, so degree of dissociate adalah 1. Maknanya completely dissociate. Alright. Okay, therefore the concentration of H plus and OH minus ion can be obtained directly from strong acid. Dia state there, strong acid and strong base, molarities. Okay, so kita tengok example. Calculate the pH of 0.15 molar mole per dm cube of HCl solution. Okay, so step number 1, buat dulu dia punya equation. Alright, HCl, pastikan letak dia punya fasa aqueous, produce H plus in bracket aqueous plus Cl minus, also in aqueous phase-nya. Alright. And then we can detect the HCl. We know that HCl is a strong acid. Therefore, HCl is 100% dissociate in water. It means given weapon. Okay, given 0.15 molar, so the H plus will be 0.15 molar also. And Cl minus will be 0.15 molar also after ionization. After ionize lah. Alright, and then from that one, you already know the value for the H plus, so you can calculate the pH value. Just insert the value of the H plus, the concentration of the H plus, by using this formula, pH equal to negative log concentration of the H plus. So, just insert negative log 0.15 molar, so you akan dapatlah pH value is 0.82. Itu adalah pH-nya. Okay. Alright. Okay.